In the course of trying to build a better guitar amp from whatever parts I've got laying around, I came across an interesting dilemma. I have this electron tube, which tested as really good on the tube tester that I just finished restoring. And I've got this tube, which tested as mediocre, or, it should be replaced. And test results on an emissions tester like this one are one thing, but how do these tubes sound? I know you can get tube testers that you can actually test the mutual conductance and you can see how well something amplifies. I don't have one of those. So what I did is I built what I call this universal gain stage, or a tube test harness, so I can see or actually hear the difference in how well or how bad a individual tube amplifies a guitar signal. The surprising thing was this tube that tested out as really good on the emissions tester sounded like complete crap. And this tube, which tests as mediocre, actually sounded really, really good, even though it's only got a mu amplification factor of about 20, and it sounded incredible. This is an eye-opening experience for me and something I think you guys would appreciate. So I want to step through the construction that I did to build this universal gain stage so you can try a project like this for your own amplification and tube shenanigans. So let's get to it. So this is a universal gain stage built around a 7-pin vacuum tube. The input signal passes through a coupling capacitor and a grid stopper resistor before reaching the tube's control grid. The cathode is biased with a resistor and a selectable bypass capacitor to control the gain and the frequency response. And the plate is loaded by a resistor connected to the high voltage power supply, and the amplified signal is taken from the plate through another coupling capacitor to the output. There's also an option for a suppressor grid, which is also connected to the high voltage power supply. Now, what makes it universal is the way that the socket is wired. Each of these pins of the socket goes to a rotary switch, and from there that pin can be assigned to any of the functions that the stage needs. If it's the grid or the cathode or the plate or the screen, or simply just left unconnected. This allows almost any 7-pin tube to be wired into the same basic gain stage without changing the circuit itself. It's basically a universal test socket that lets you plug in almost any small tube and try it out as a gain stage. This power supply is a bit of a Frankenstein build, put together from repurposed parts. Everything starts with this 9-volt AC wall adapter. From there, the voltage splits into 2 paths, one for the high voltage and one for the tube's filament. For the high voltage, I used a small transformer backwards to step things back up to 120 volts. Then I ran that through a rectifier and a filter cap. That gives me about 175 volts DC for the tube's B+ supply. Now, to keep it safe, I added this 10 meg resistor across the filter cap. It slowly drains the voltage when the unit is powered off, so the cap doesn't hold a dangerous charge. The other path handles the filaments. The 9 volts AC is rectified, filtered, and then sent to a DC-DC buck converter, which lets me dial in exactly the heater voltage I need for the different tubes. And all of this is mounted in the cigar box, held down with plenty of hot glue, and wired together with scraps of old doorbell wire. It's not fancy, but it's solid, safe, and does the job perfectly. For the front panel, I started with a printout for this front label. It gave me an identifier for each of the functions, and it also acted as a drill guide so I could evenly space out each of the switches. Now, to wire these things up, I first placed the switches inside of the holes that I drilled and filed out to neaten up. then lining up each of the switches in the same orientation. I took a length of wire and connected all of the pin 1s together to form a bus that I could connect to the corresponding pin on the tube socket. I repeated that process for pin 2 all the way through to pin 7. The center pin of each of the switches got a color-coordinated wire so I could identify what function it was later in the circuit that I would place. Once all of the switches were wired together, I removed them from the outside of the front panel and then placed the whole assembly on the inside of the cigar box. To make sure that I had the correct wire from each of the wires in the bus, I wound up using a continuity test on the voltometer. One probe was hooked to the colored wire for the specific function, and the other probe tested each one of these identical white wires on the bus until I found a match. This was a tedious process, and it actually took about a day or two to get that entire process done. Once everything was connected, to finish the look, I put these nice MXR style knobs on each switch. It gives it a nice finished look, I think. For the components that would make up the circuit, I laid out each of the components I picked out for the pots, the caps, and the switches on a copy of the schematic. And after I had everything selected, I started making some sub-assemblies, starting with the bypass cap that would connect to the cathode. And I had a list of capacitors from 220 nanofarad all the way up to 220 microfarad. And the last position on the switch was no connection. Following that, I made a quick sub-assembly for the output jack with a 1 meg resistor and 1 microfarad coupling capacitor. And for the input jack, the 47 nanofarad capacitor was connected to the poles of a single pole switch. With all of the sub-assemblies and components selected, a quick visual layout on the top of the box, marking spots with a ruler and a pen, it was a quick matter to drill out all of the holes and then file everything smooth. If this was a wooden box top, I probably wouldn't have to file everything down. With all the components mounted to the top of the box, I know from past experience it helps to write down the values of all of the components and put a little bit of schematic information, like where to place the ground, for reference as I connect everything together. Following that, picking out a couple of decent knobs for each of the potentiometers, and some additional markings for the component values and switch positions for reference later definitely comes in handy. There's even a list of the bypass caps that I taped to the lid. Now, connecting the different parts of the circuit inside, continued use of the color-coded wire really helps for a visual reference of what everything is later, just in case I need to open the box and take a look at something. This is going to conclude the first in the series for the tube test harness. I want to put a sound demo on here, but the build video has already gotten long enough that I want to do the audio demo some justice because I want to test different tubes and other setup issues that I have to tend to as well. We'll get to that later. And if you're liking this kind of stuff, do consider subscribing so you can catch up on that stuff later. I'd love to see you there. Catch you next time.